Chapter 34, Glaucoma and Genetics, specifically open-angle glaucoma, which is an eye disease. Alright, here you see a cross-section of an eye, and the normal process is that blood vessels supply the cells within the eye. They're light-sensitive cells that help you see, and they supply them with oxygen and nutrients that the cells require to survive. And also in the back of the eye, the eye continuously produces fluid, clear fluid that keeps the eye inflated, kind of like a balloon, a water balloon. And this fluid travels through the eye, and then it exits through channels at the front of the eye. And it's always produced and it always exits, and by managing how much is produced and how much exits the eye, the eye can be completely inflated all the time without having too low or too high pressure. And this genetic or this gate or this channel of where the fluid can leave the eye is controlled by the LOXL1 gene. And this gene can, when it has a genetic variation, influence the gate and cause the following problem. The eye keeps producing liquid, but it cannot leave the eye as efficiently as it could, but the eye continues to produce more liquid, and this then starts to accumulate and it increases pressure. And there is blood pressure which presses the blood into the eye to make sure that the cells get the nutrients and oxygen. And now inside the eye, pressure increases and it works against the blood pressure. And eventually it starts on the outside. The blood is forced out of the eye and then the cells begin to die. And so it starts on the outside and it goes progressively further inwards, and a lot of cells start to die off. So it's increased intraocular pressure and the cells die, and the external field, the field of vision as the cells die from the outside, it starts to reduce or become more constricted, just like you see here in these images. So you lose more and more of your vision around, while the vision in the center of your eye is unaffected. So it's kind of like the opposite of macular degeneration, in case you've seen this training. The brain is quite good in balancing out any kind of vision loss that you have experienced, because you might miss this corner up here, but the other eye can see it, and so your brain just interprets the image into it. So usually it takes very long for you to actually realize that you have restricted vision. And once you see that you have the first symptoms, then up to 95% of all light-sensitive cells in the eye have already died, and they will not come back. So this is permanent loss of vision. And it's a pity, because there are very effective drugs. There are eye drops that can open these channels and help you prevent the disease. So really, if you go to your doctor, he measures the signs for glaucoma and he detects it, it's very easy to treat. However, 60 to 70% of people don't go to eye doctors often enough, and so this genetic test can increase awareness, especially in people with an increased risk. So what can a genetic test tell us? For one, it can tell us the genetic risk. So you might have a low genetic risk of a 1-fold risk, a medium risk, twice as high, or a high risk when all of the genetic variations come together, then it's an 11-fold risk, meaning this person has an 11-fold higher risk of developing, or higher likelihood of developing, the disease than a person in the low area. And now let's compare two people with different genetic outcomes. As I said, around 60% of the population do not go to eye checkups. And a person where we do a genetic test that has a 1-fold risk would be recommended to go to regular eye examinations. There is not just glaucoma, but there are some other diseases that should be detected. That's why it's important to go to eye checkups. If a person has an 11-fold risk due to high risk of genetics, we would recommend earlier, more regular and more precise eye examinations. So there are a number of tests that a doctor can do, not just eye pressure. And also if you know that your risk of developing the disease is 11-fold higher than that of most of the other people, we find that it really motivates people to have the eyes checked up because they know this is more important for them than for everybody else. So this 60% don't go to eye checkups rate is really going down in people that know they have an increased risk. And then when the disease occurs, there's very effective treatment with eye drops, and this can protect the sight of people with a high increased risk. And this here is the genetic basis of it. In case you're interested and you don't know what this means, there is a training for simple disease risk statistics that will explain it to you. In this case, this is the result of the person, TT, so every gene has a T on in this position. 2% they would not have an increased risk of glaucoma, so they actually have a kind of protection, and most of them have an increased risk. So having a high risk in this field is not unlikely, which also means that most people that develop it will have a very high risk, and that people that have low genetic risk are very, very unlikely to develop it at all. So here you will see this bar, and you will have the arrow wherever you're located. For people that are here, we would recommend normal eye checkups, and if the arrow is here, it's very important for this person to go to regular eye checkups, because odds are this person is part of the 60% that don't go to eye checkups, and it's very important for them, much more than for the other people that have a lower genetic risk. And that's the end of chapter 34, Glaucoma and Genetics as Training for the Glaucoma Sensor.